A simple random sample of size 36 is obtained from a population with mean 71, standard deviation 18. Describe the sampling distribution of X bar. So that would be normal because sample size is bigger than 30, approximately normal. Find the mean and standard deviation of the sampling distribution. So mean is the same, 71. And standard deviation is the original standard deviation divided by square root of the sample size. So that would be 3. Probability X bar is bigger than 77. So let's do stat crunch. So now the difference is that, so do I have a stat crunch window open? Okay, I do. So once again, it will be stats calculator normal. And the difference now is that we will be using the mean and standard deviation of the sample and not for the original data. So mean, you know, is the same. So mean was 71 always. But the standard deviation was, look, the original standard deviation is 18. That's for the X. But we are asked question about the X bar. So you will use the standard deviation for the X bar, which is 3. So that's the only difference. Otherwise, it's the same working as before. And this was 3, and we were looking for greater than, I think. Let's go back. Yeah, greater than. Oh, well, okay. We were looking for X bar greater than 77. So 77 comes here, and 3 is in the standard deviation. So 0.0228. X bar less than equal to 64.25, so same thing. Now you do less than, and then for part D you do between. So just skip that. Okay, the mean of distribution, mean distribution of the time required to get oil change. The 20-minute facility is unknown. However, records indicate that the mean time is 21.9, the standard deviation 4.7. To compute the probabilities regarding the sample mean using normal model, what sample size is required? So we need greater than 30 because we are not told that the original distribution is normal. So now we have to have sample size bigger than 30. Needs to be greater than 30. What's the probability that a random sample of size 45 oil changes results in a mean time less than 20 minutes? So mean is 21.9. So let's see, in the normal calculator, the mean is 21.9. And now remember, the standard deviation we will use will not be this 4.7 because that's for one oil change. And you were asked question about 45 oil changes. So it would be 4.7 divided by square root 45. 4.7 divided by square root 45. So you can just write 4.7 divided by SQRT. SQRT is the standard notation for square root, 45 in parentheses. So that does the standard deviation for you. And the question was, what's the probability that the time is less than 20 minutes? So you would do less than 20, change it to less than. 0.0033. And then suppose the manager agrees to pay each employee a $50 bonus if they meet a certain goal. Typical Saturday, the oil change facility will perform 45 oil changes between 10 a.m. and 12 p.m. Treating this as a random sample, at what mean oil change time would there be a 10% chance of being at or below? So remember, 10% is the probability or the area. So that will go in the area box and we're that or below. So 10%. So 10% goes in the area box, 0.10. At or below. So we're already at or below, less than or equal to, and everything else is the same. And this gives us 21. Round to one decimal place, it was 21.00, so 21. Come on.